This video is going to be modeling for you and discussing some of the area concepts that we will work on in third grade. In third grade, we focus on area of rectangles and rectangle-like shapes, or they're called rectilinear, which will be later on in the unit. But first, we're just going to look at the area of a rectangle. So to get all on the same page here, area is the amount of flat space that something takes up. When your children get older, they'll learn about volume, which is also going vertically, so kind of 3 different dimensions. But area is just the flat space that it's taking up. And in the real world, when we think about area, we might be thinking about carpeting that we're putting down, or paint that we're putting on a wall, or tiles that we're putting on the floor or on the wall also, or how much space my table is giving me or taking up. So all of these ideas in the real world take up space, some flat space, so we use area to measure them. And you'll see in a moment why area is always measured in square units. So when we have a rectangle, let's look at this one here, this first method of tiling. So we have this rectangle here, and if we're trying to figure out all of the flat space, then we need to know all of the area on the inside that it's taking up. So what we do is we use tiling. And so tiling is you're just making little squares inside of it, and that's why it's called square units. If you have something large, then you might be using square feet. So each square unit would be 1 foot, 1 foot, 1 foot, 1 foot. If you have something small, you might be doing centimeters. So it might be centimeter, 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 centimeter. If you have something really, really, really big, you might be doing miles. So each unit would be 1 mile, 1 mile, 1 mile, 1 mile around. So the first method that we use is tiling, and that is right here. And when you see something that already has been filled in with square units, then all you do is count them. You just count how many squares there are in there. So 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. So this rectangle here has an area of 10 square units. You want to be careful that you don't count the lines. It's not 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. Because as you can see, I got 12 there, but the area is actually of the units, which is 10 square units. Now, if you are given some dimensions, some measurements, and you're asked to use tiling, then this is what I typically do. So they're telling me that I want to use tiling to show the area of something that is 3 feet long, 4 feet wide. So what I typically do is I will make something that is 3 feet long, and then when I'm looking wide, I see 4 wide. You got to be careful. This one kind of gets counted with length and width. And then I'll use that to kind of help me fill in. Now when I look at it, is it perfect? No. Did I give my best effort to make some square units? Yes. So now what I can do is I can count these tiles. So 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. So the area of this is 12 square feet. And you'll notice that here I did square feet because I was given a unit. Here I was not given a unit, so I just said square units. So this is tiling. Now you might look at tiling and start noticing that it kind of reminds you of arrays that we used in multiplication earlier in the year. And so that's where the multiplication equation for area comes from, is because there are rows and columns here. So if you notice here, this is 2 groups of 5. Here's a group of 5, here's a group of 5. And when I multiply 2 times 5, I get 10. Or here you'll notice I have 4 groups of 3. Group of 3, group of 3, group of 3, group of 3. 4 groups of 3. 4 times 3 is 12. And as you can see, I got 12 square feet by counting the units. So that's where the multiplication equation for area comes from. It's actually invisible arrays that are inside of that area. Invisible little squares that are actually making arrays when they're all lined up. So once we've practiced tiling, we can then start to just visualize the tiling as we're doing multiplication was a little more efficient. So here I'm going to draw a rectangle, and I'm going to write in the dimensions here that they gave for me. So they're saying the classroom is 7 yards long and 9 yards wide. So I'm taking these dimensions, I'm giving myself a visual, because now I can visualize 7 rows of 9 tiles inside of there. And after I visualize that, I can know, oh, I'm just going to use the multiplication strategy of 7 times 9. There's 7 groups of 9 invisible little squares inside of here. So 7 times 9 I know is 63. Now, since I'm using area, I need to do 63 square yards. Okay, so multiplication is the more common method, but it comes from this. It comes from tiling, that there's these invisible little arrays going on inside of there to fill up this space. Now, moving on a little bit step further with another connection to multiplication is the distributive property. Sometimes you get areas that are huge and you have to figure out the area of them. So here, my multiplication equation would be 4 times 13. But if that's a little unmanageable for you and you think, oh, I don't really know how to do 4 times 13, that's a little bit large, you can break this side up a little bit. You can break this area into smaller parts, do easier multiplication, and then add the areas back together, just like we do in distributive property for equations. So here, I'm going to take this 13 and I'm going to break it up instead into, well, since it's a 2-digit number, using the place value is kind of the easiest way to do that. Now here's where things get a little bit tricky. So here, I have my sides. I can do 4 times 10. Over here, I don't know this side, but I got to use the properties of what I know about rectangles. If this side is 4, then this side is 4, and if this side is 4, then this side is 4. So this is also 4. So here, I can multiply 3 times 4 for the area of this smaller part. So when I do that, this is 40, and this is 12. And then I'm going to join them back together and get 52 square units. That would be the same as me doing 4 times 13 in an equation. I can just break it up into 4 times 10, 3 times 4, and then joining them back together to get 52. So that's the distributive property here when we're using an area. So these are 3 different methods that all kind of connect to each other. Area really is this, but this is a more efficient strategy for using that, but you still got to kind of visualize the rows and columns inside. And then this is what we use when, our numbers get really big and we're trying to break it up a little bit. So here is the concepts for area of a rectangle in 3rd grade. So use these when you're doing your homework or when you're practicing at home.